alaikum. Physical Geology course, Chapter 6, Weathering, presented by Khalid Lamrouni, PhD of Geology, Texas A&M University. And Khalid Lamrouni is a staff member at the Department of Earth Sciences, Yunus University, Benghazi, Barga State, or Cyrenaica State. The reference used here is Essentials of Geology. This is the Earth Sciences Department at Yunus University, and this is the main entrance of Yunus University. And here's the Prince of Cyrenaica Idris Sanusi and the founder of Yunus University. And here's the flag of Cyrenaica behind the Prince Idris, Prince of Cyrenaica. This is the Chief Commander of the Sanusi Army, Omar al-Mukhtar. This is the capital, Benghazi City, the capital of Cyrenaica State. And this is the map of Barga State, or Cyrenaica State. The outlines of the weathering chapter. Weathering, mechanical and chemical, and rate of weathering. And we study erosion, mass wasting, soil, and controls of soil formation, and the soil profile, and the soil types. And then the following chapter will be sedimentary rocks. Weathering and sedimentary rocks. So materials removed from higher to lower elevations by continual processes, which are weathering, erosion, and mass wasting. So what's weathering? Definition. Disintegration and decomposition of rocks at or near the surface of the earth. So weathering means the material or rocks will be broken and fragmented into pieces, smaller pieces, at the Earth's surface, in situ, not to be transported, in situ. Now the second part, erosion, incorporation and transportation of material by mobile agents. Which material? The weathered material. By mobile agents, usually water, wind, or ice. So erosion is the transportation process, incorporation and transportation of the weathered material. So to remove the material, now you're going through the next step after weathering, which is erosion by water, wind, or ice. There's another process we call mass wasting, transfer of rock material down a slope under the influence of gravity, another agent of transportation, gravity. Weathering. So let's see some literature. Is the response of Earth's material to a changing environment. Rock mass will gradually change until it's once again in equilibrium or balance with the new environment. And we have two types of weathering usually work simultaneously in nature. They are chemical and mechanical weathering. So weathering has two types, mechanical and chemical. So what's mechanical weathering? Mechanical weathering is the breaking of rock into smaller and smaller pieces, each piece retaining the characteristics of the original material. So mechanical weathering, fragmentation of the rock into smaller pieces without changing the original composition of the material. No chemical changes, nothing, just fragmentation into smaller material or smaller pieces. But what happens when we break down the rock into smaller pieces? That will increase the surface area available for chemical attack. So the mechanical weathering breaks down the rock into smaller pieces and made the exposed surface area bigger, and that will help the next step or next type of weathering, the chemical weathering, to attack larger surface area. In nature, there are four important physical weathering or mechanical weathering. Mechanical weathering, we call it physical weathering too. It has another name. That lead to the fragmentation of rock into smaller pieces. First one, frost wedging. Second one, expansion resulting from unloading. The third one, thermal expansion. And the fourth one, organic activity. What's frost wedging? water works its way into cracks, especially in the mountains, or voids in the rock. And upon freezing, when the water freezes, the size of the water, the volume will increase, and that in expanding and wedges the rocks apart. That means breaks the rock apart. Unloading this process, we'll see the pictures for this and explain. I'm just reading the definition. Unloading this process includes two main types, which are sheeting, exfoliation, and domes. Sheeting sheeting exfoliation domes. Sheeting when large igneous bodies, granites, are exposed by erosion, concentric slabs begin to break loose. And exfoliation domes, this is the second part, and creates exfoliation domes. Then the thermal expansion, due to the daily cycle of temperature change, the rocks will be weakened in hot, dry regions, especially in the desert, because the temperature is too hot, too high during the day, and then freezing cold during the night, and that causes expansion and contraction of the rocks, or rocks and grains, and that will lead to the fragmentation of the rocks. And the last one, organic activity. It's accomplished by the activity of different organisms, including plant roots, burrowing animals, and human. So all of them. So let's go through the the increase of the surface area. So this cube has 6 sides, and it has 4 square units for each side. 4 square units times 6, because 6 sides will give us 24 square units. This is the surface area. If we break it down to 8 cubes, due to mechanical weathering or physical weathering, so and each cube has 1 surface or square unit. So 1 square unit times 6 sides, times 8 cubes, will get 48 square units. So the area doubled from 24 to 48. If we have 46 cubes like this, so 25 square units, 5 times 5 each one, times 6 sides, times 64 pieces or 64 cubes, we'll get 96 square units. So the surface area increased. When we have larger surface area, that will make it easy for the chemical erosion to break down and dissolve the rock into elements. So let's go through the frost wedging, first mechanical weathering process. So here in the mountains, we have cracks, and this crack, the water percolated inside the crack, and then it got frozen. When the water got frozen, the size will expand and the size will increase, and that will cause pressure along these fractures and break the rock into smaller pieces. And these smaller pieces will fall down as debris and form talus slope, which is made up of fragments. So this is the first mechanical weathering or physical weathering process. The second one, exfoliation of igneous rocks. So we have here granitic body, igneous plutonic, under the load of the sediments. When the sediments, that creates confining pressure. When the sediments eroded, this body will be exposed on the surface, and fractures and joints will form parallel to the surface. And weathering will start taking down this granitic rock as slabs or sheets. And this is the example of the exfoliation of the igneous rocks. Now, weathering, the chemical weathering. Chemical weathering is different than mechanical. It's a complex process which alters the internal structure of minerals by removing or adding elements. So mechanical weathering or physical weathering no change in the chemical composition of the rock. But in the chemical weathering, we have water, moisture, and the mineralogical composition will change either by removal or adding elements to the rock. The processes in which the water decompose rocks are hydrolysis, solution, or oxidization. For example, feldspar, if it's exposed to chemical weathering, will change or transform into clay minerals. And a clay mineral is very stable under surface conditions, which is shale, sedimentary rock, is made of clay minerals, for example. Sand, quartz, can be the opposite, lithified to sandstone. This table shows the products of weathering. So if we have minerals like quartz, feldspar, hornblende, olivine, will produce residual products, the hard that stays in hard parts, and minerals in solution. So quartz is, if it's exposed to chemical weathering, will have quartz grains plus silica in the solution, Si2. Feldspar, if exposed to chemical weathering, the residual will be clay minerals plus the solution in water. Silica will dissolve, potassium will dissolve in water, sodium and calcium will dissolve in water. Hornblende will form clay minerals if subjected to chemical weathering and give us limonite and hematite, plus the dissolution will include silica, calcium, and magnesium. Olivine will give us limonite, hematite, plus silica and magnesium in solution. So residual material, hard material, plus solution. This table is very important. Rates of weathering. Rates of weathering depends on two main factors: mineral makeup or mineral composition of the rock, and the climate. Climate mainly temperature and moisture. And the best environment for the chemical weathering, warm environment, warm and humid, which is warm temperature and abundant moisture. But chemical weathering is ineffective, not working in polar regions and high altitudes. Because of what? Because of frigid temperature keep the available moisture locked up as ice. So there is no moisture. And the same thing in the arid regions, there is insufficient moisture. So in the arid regions, no moisture. So in arid regions, no moisture, just mechanical weathering working. In the same thing in polar regions, no moisture, just mechanical weathering. No chemical weathering in polar regions, no chemical weatherings in arid regions. Soil or regolith. Regolith, the layer of rock and mineral fragments produced by weathering and the accumulation of weathering debris. Soil is a combination of mineral, organic material, water, and air. Four things in the soil. Controls of soil formation. Complex interplay of several factors, including parent material or parent rock, time, climate, plants, animals, and slope. So parent material, time, climate, slope, and plants and animals. So parent materials. Here we have residual soil and transported soil. Residual soil is the underlying bedrock, soil formed on bedrock. So when you have residual soil, that means the soil formed above the bedrock. The transported soil form on unconsolidated deposits. So the transported soil, that means the soil formed somewhere at the bedrock and then transported down and deposited at another place as unconsolidated deposits. Note, soils are thinner or non-exist on the slopes. We'll see that in the next picture. The climates. determines whether chemical or mechanical weathering will be predominant and also greatly influence the rate and depth of weathering. As we said, climate, if it's a humid climate, has moisture, will have chemical weathering, dominant chemical. If it's dry, we'll have mechanical weathering or physical weathering as a dominant weathering factor. Plants and animals, the chief function of plants and animals is to supply organic matter to the soil. So organic matter suppliers. Slope affect the amount of erosion and the water content of the soil. And also in the slope, if the slope facing the sun direction, that will affect the the amount of the sunlight the slope will receive and the amount of moisture that the slope will retain. And that will influence the vegetation and the soil character. So let's look at the soil here. We have this profile, we have a cliff here, and we have a valley, has unconsolidated sediments. And here we have flat terrain. The soil here, this is residual soil formed above the bedrock. So this soil coming from the weathering of this bedrock and stayed here. This soil here transported from this side or transported from the top side of the valley, like the valley head, and then deposited here. So this soil is not coming from the bedrock. It's coming from the head of the valley or the sides. And this is what we call unconsolidated or transported soil. On the sides here of the cliff, soils cannot stay because it's very steep. So anything will fall down to the valley. The components in a soil, or typical components in a soil should be 45% minerals, 25% air, 25% water, and 5% organic matter. Okay, the soil profile. The profile is a vertical section through the soil showing its succession of horizons and the underlying parent material. We have two definitions here. Elevation, which is washing out of fine soil components. When fine soil components washed out, we call it elevation. Leaching, which is depletion of soluble materials from the upper soil. And usually you'll have the very white color, light color. Mature soil and immature soil. We have two types of soil. The mature soil are characterized by series of horizontal layers called horizons, which comprise the soil profile. So the soil profile should have horizons to say it's a mature soil. Immature soil lack horizons altogether, no horizons, because soil building has been going on for just only short time. So it needs more time to build the soil profile. Immature soils are characteristics of steep slopes. Steep slopes have no mature soils, where erosion continually strips away the soil, preventing fall development. So let's look at the soil profile. Here at the bottom we have an altered parent rock, and then above it partially altered or parent rock. And then we'll have this zone, the leached, the clay zone, which is accumulation of clay transported from above. And then above it there's this light zone, which is the zone of elevation and leaching. And then above it the organic rich zone, mineral rich and organic rich zone. It has two zones. One, this is the thick zone, the brownish dark brown, and this deep dark brown to black, the very organic rich zone, which is partly decayed organic material. But here we have organic material, call it humus, mix it with minerals. So this is the full soil profile: an altered bedrock, clay materials, elevation and leaching zone, And then the next horizon is the mix of minerals and organic material called humus. And then the very top, very dark one here, just partly decayed organic material. And they're called Zone C, Zone B, Zone E, Zone A, and Zone 0. This is soil profile showing different zones. Here, the organic material zone, and this is the mixed organic and minerals zone. Here we have plants dry. And here the white, this is the leaching zone and the irrigation zone, and this is the partially altered or partly altered parent rock. This is full soil horizon or soil profile. Soil types. Based on climate, we'll have different soil types. If it's temperate, humid, and rainfall is more than 36, we'll get bit alpha, which is rich in aluminum and iron. And if it's temperate, the climate, and dry, here temperate and humid, but this temperate and dry and the rainfall is still high, more than 63%, we'll get pedalcal, which is rich in calcium. If it's a tropical, heavy rainfall, the climate, we'll have laterite, which is very rich in iron and aluminum. And then if it's extreme Arctic or desert, no real soil, no soil, there is no organic matters and no moisture. Okay? Take-home message, weathering is sedimentary rocks, and we saw the weathering is mechanical and chemical and rate of weathering, and then we talked about erosion, mass wasting, and then soils, controls of soil formation, the soil profile and soil types, and then sedimentary rocks. As geologists, we talk about soil because the soil profiles because it's very important when we study unconformity surfaces that exposed on the surface. Because soils form on the unconformity surface, and that will help us to define the unconformity surfaces. And there's one point here I need to go back to the 4 types of mechanical weathering. This point where's the thermal expansion. So in deserts, the temperature will increase during the day about 50 degrees Celsius and goes down to the freezing point or under during the night. And we know rocks made up of different minerals, and each mineral has different rate of expansion and contraction. And when that happens over the time, expansion and contraction with different rates, that will create cracks inside the rock fragments, and the fragments will break down over time. And during nighttime in the desert, they hear a lot of whistles. So that's just the fragmentation and breakdown of the of the rock fragments during nighttime due to the expansion and contraction. And by this, we conclude the lecture for the for the weathering, and we'll listen to the 3 minutes to the national anthem of Sri Lanka. Thank